So hello everyone. The reason I'm making this video is some people had questions on problems 17 and 18, and basically it's telling you that you earned $50 in interest on a $1,000 deposit. You got that in 8 months. So if the effective annual rate is the same and is not a function of the length of the investment, how much will you earn on a $1,000 deposit for 6 months, 1 year, and 1.5 years? All right, so first of all, you got to calculate the effective annual rate here, right? And we use, I believe it was equation 5.1 we use, right, if I'm not mistaken. We put the APR in here. And this gives us an annual rate, and it comes out when you just do the simple math here, 7.593%. Now what we've got to do is get the rate for each period using a similar formula, but now we plug in the effective annual rate in here, because now we have the effective annual rate, which doesn't change, as they said. And now we know what the interest was $50 for 6 months. So here now it becomes, if we take the equation here with this equation and put 1,000 times 1.07593, and it's 6/12 minus 1. That's this equation, right? So we get the end period discount rate and multiply it by 1,000, and it comes out to 37.27. And over here it comes out to, if we have 1 year, this becomes 1/1, right? You can see that. And it's 1,000 times 1.07593. It's 75.93. And for 1.5 years, now this becomes 1.5, right? So you notice this could be larger or smaller than 1, right? You see that? And that becomes 116.03. Okay? So we computed the amount of money on that $1,000 deposit. So again, we just used that one simple equation that we had. I believe it was 5.1, and we got the effective annual rate, and then we got the effective annual rate for different periods. I hope that's clear to everyone. All right, now let's go to question 18. Suppose you invest $1,000 in a bank account, and 5 years later it has grown to $134.39. What APR did you receive if the interest was compounded semi-annually? And what APR did you receive if it was compounded monthly? All right, so we need to calculate the effective annual rate. And this is basically, we have a future value, right? We have the present value we invested, the $100, and then we have the future value. So we can actually use Excel for this, but basically, we need the effective annual rate, right, that we received first. So we get the effective annual rate by getting the future and the present value, which we haven't gone over much of this in class, the future and present value. I know that, but we'll go over that more. And we'll get that. And again, you could put this in Excel, and it's to the 1/n power, right? And once we plug that in here, we end up with 6.0897 as the effective annual rate, okay? All right, so once we have the effective annual rate, now we can get the APR. We take the other effective annual rate equation we have, and we reshuffle stuff around in that equation and to get the APR. Okay, and the APR can be found as for part A as 5.90997%. So that's for semi-annual compounding, and that rate also can be found for monthly compounding. You'll notice I put 1/12 here, right, as 5.9261%. So again, this is the equation. I believe this is either 5.2 or 5.3 in the book. Okay. This basically I kind of didn't go over that much, but we'll spend more time going over this stuff. Okay. Alrighty.